Half of the available inventory was gone within just 24 hours. We're not talking about a smartphone launch or a flash sale on consumer electronics. We're talking about Class 8 heavy-duty trucks, vehicles that cost between $250,000 and $300,000 each. Yet 50% of Tesla semi-production slots disappeared from the ordering system before many people had even finished their morning coffee. According to market analyst Sawyer Merritt, that's exactly what happened. If you think this is just another wave of electric vehicle excitement, think again. Some of the most experienced logistics executives in America are no longer watching from the sidelines. They're engaged in a fierce competition, not with weapons, but with freight networks, supply chains, and the economics of survival. The real question is, are we witnessing the beginning of the end for diesel trucking? Or are we watching one of the most expensive transportation experiments ever unfold? The logistics battle few people are talking about Tesla officially began mass production of the Semi at Gigafactory, Nevada on April 29, 2026. The company aims to produce thousands of trucks before the end of the year, with a long-term goal of reaching 50,000 units annually. What's often overlooked, however, is that customer demand isn't the problem. Production capacity is. The biggest obstacle isn't finding buyers, it's building trucks fast enough to meet demand. That reality became clear when Watt EV placed a $100 million order for 370 Tesla semis in early May. This wasn't a speculative move or a publicity stunt. The company made its decision because the numbers showed that waiting could mean losing a competitive advantage. The first 50 trucks from that order are expected to be delivered before the end of the year. The momentum doesn't stop there. California's Hybrid and Zero-Emission Truck and Bus Voucher Incentive Project, HVIP, reported purchase commitments from 89 different fleets, totaling 1,095 vehicles before the end of the first quarter alone. Think about that for a moment. 89 independent fleet operators competing in one of the world's toughest freight markets, all arrived at the same conclusion around the same time. This isn't simply enthusiasm for new technology. It's a recognition that the industry is changing rapidly. When one company adopts vehicles that dramatically reduce operating costs, competitors face a difficult choice: adapt or risk operating at a permanent disadvantage. Industry strategists have a name for what's happening: a first-mover advantage race. Companies that secure early production slots gain access to lower operating costs sooner. Every mile driven by an electric fleet at reduced energy costs creates a financial advantage over competitors still dependent on diesel fuel. And that advantage doesn't disappear over time. It grows. For companies that have relied on diesel for decades, the reality is becoming increasingly difficult to ignore. The race has already begun. Early adopters aren't just purchasing trucks, they're buying a head start. Those who delay aren't standing still, they're falling behind. The price tag. That doesn't tell the whole story. This is where the discussion becomes uncomfortable for diesel supporters. At first glance, the Tesla Semi appears expensive. A conventional diesel Class 8 truck typically costs around $172,500. The Tesla Semi starts at approximately $260,000, while the long-range version can reach $300,000. That represents a price difference of roughly $90,000 to $130,000 per vehicle. For a fleet operating 100 trucks, that additional upfront cost can seem overwhelming. But the sticker price only tells part of the story. Competing electric trucks often cost around $411,000. Compared with that benchmark, the Tesla Semi isn't overpriced. It is competitively positioned. The economics become even more compelling in California, where the HVIP incentive program can provide up to $120,000 per vehicle. With those incentives applied, the effective purchase price of a Tesla Semi becomes far more attractive and can even challenge the economics of diesel ownership. Then there's the cost of operation. Diesel prices along major freight routes have climbed above $7 per gallon in several regions. A long-haul diesel truck averaging 10 miles per gallon on a 500-mile trip consumes approximately $350 worth of fuel for a single run. A Tesla Semi can complete that same journey on a single charge using electricity at a fraction of the cost. When those savings are multiplied across hundreds of trucks making thousands of trips every year, the initial price difference begins to look very different. What appears to be a $130,000 premium may actually be an investment in a fundamentally different operating model, one designed around lower energy costs, reduced operating expenses, and long-term financial efficiency. Maintenance savings that go beyond fuel costs. The financial advantages of the Tesla Semi don't stop at lower energy costs. In many ways, maintenance savings may be even more significant. Traditional diesel trucks rely on complex drivetrains that require constant upkeep, regular oil changes, transmission servicing, exhaust system repairs, coolant maintenance, and the replacement of filters, belts, and numerous moving components are all part of routine operations. These parts operate under intense heat and mechanical stress, making wear and tear unavoidable. Electric drivetrains are fundamentally different. With far fewer moving parts, significantly less heat generation, and reduced mechanical complexity, many of the maintenance requirements associated with diesel trucks simply disappear. Service intervals become less frequent, and long-term repair costs can drop dramatically. When fleet operators analyze total ownership costs over a typical 7-year operating cycle, many are discovering that the higher purchase price of the Tesla Semi is recovered much sooner than expected. What Tesla has effectively created is more than an electric truck. It's a different financial equation. The higher upfront cost may seem like a barrier at first, but over time it is offset through lower fuel expenses, reduced maintenance costs, and government incentives. As those savings accumulate year after year, the initial premium becomes increasingly difficult to justify against a traditional diesel alternative. The battery technology behind the Tesla Semi. To understand how the Tesla Semi competes with diesel trucks on long-haul routes, it's important to look at the battery technology that powers it. Information revealed through California Air Resources Board filings shows that Tesla's approach is far from incremental. It represents a major leap forward in commercial trucking. The standard Tesla Semi is equipped with a usable battery capacity of 548 kilowatt-hours, while the long-range version carries approximately 822 kilowatt-hours of usable energy. For comparison, a standard Tesla Model 3 uses a battery of roughly 64 kilowatt-hours. That means the long-range Tesla Semi carries nearly 13 times more energy capacity than one of Tesla's popular passenger vehicles. This enormous battery pack enables the long-range Semi to achieve a real-world operating range of around 500 miles. When charging is required, Tesla's megawatt-class charging system can restore approximately 60% of that range in about 30 minutes. What's particularly important is that this charging time closely matches mandatory driver rest breaks required under federal hours of service regulations. In other words, the truck can recharge while the driver is already required to stop and rest. The charging process isn't necessarily creating additional downtime. Instead, it takes advantage of time that is already built into the trucking industry's regulatory framework. For fleet operators, this changes the conversation entirely. The charging delay that critics have highlighted for years becomes far less significant when it overlaps with legally required rest periods. The driver takes a break, the truck recharges, and the journey continues. The operational workflow remains largely unchanged, but the fuel costs are dramatically lower. The Grapevine Challenge, where electric trucks were expected to fail. One of the most common criticisms of electric trucks revolves around performance under heavy loads and steep terrain. Critics often ask the same question. It's one thing to drive efficiently on flat highways, but what happens when an 80,000-pound truck has to climb a steep mountain grade? Covenant Logistics decided to put that question to the test. The company, which operates more than 2,600 tractors throughout North America, conducted a 2-week real-world evaluation of the Tesla Semi on one of the most demanding freight routes in the United States, the Grapevine section of Interstate 5 in California. This wasn't a controlled demonstration or a carefully managed publicity event. There were no closed courses, no ideal weather conditions, and no artificial test environment. The Grapevine was selected specifically because professional truck drivers know how challenging it can be. The route crosses Tejon Pass, which rises to approximately 4,160 feet above sea level and represents the highest point along California's Interstate 5 corridor. Northbound trucks must climb long, steep grades while carrying full freight loads. In diesel trucks, maintaining momentum on these climbs can be a constant battle. Drivers often experience repeated gear changes, fluctuating engine speeds, and gradual losses in velocity. A single heavily loaded truck struggling on the incline can slow traffic and create bottlenecks for miles. Anyone who has driven a loaded diesel truck up the Grapevine understands the experience of watching speed slowly disappear while managing gears and engine performance in an attempt to maintain momentum. The Tesla Semi approaches the challenge differently. Its tri-motor electric powertrain delivers maximum torque instantly from 0 RPM. There are no delayed power curves, no gear changes, and no waiting for engine speed to build. As the slope becomes steeper and resistance increases, the electric motors simply draw more power and continue producing strong pulling force. There is no ideal RPM range to maintain and no transmission searching for the correct gear. Power is available the moment it's needed, providing smooth and consistent performance throughout the climb, regardless of how many miles the truck has already traveled that day. The descent. An often overlooked challenge. Climbing Tejon Pass is only part of the test. The descent presents its own set of challenges and exposes limitations that diesel technology has long struggled to manage. Southbound traffic descending from Tejon Pass drops approximately 2,613 feet in just 11.6 miles. The steepest section of the Grapevine maintains an average grade of roughly 6% over about 5 miles. For a fully loaded Class 8 truck, that descent ranks among the most demanding situations a professional driver can encounter. Managing speed, controlling brake temperatures, and maintaining vehicle stability become critical concerns. Every decision made during the descent can impact safety, vehicle wear, and overall operating efficiency. And it is on these demanding downhill sections that the differences between conventional diesel technology and modern electric powertrains become even more apparent. When gravity becomes an advantage, one of the toughest challenges for any heavy truck isn't climbing a mountain, it's coming back down. When tens of thousands of pounds of cargo are pulled downhill by gravity, the braking system must constantly control the vehicle's speed. Traditional diesel trucks rely on engine braking and friction brakes, which convert that energy into heat. The problem is brake fade, a concern every experienced truck driver understands. As brakes heat up during long descents, their effectiveness can decrease, creating safety risks and increasing wear. On steep routes like California's Grapevine, drivers must carefully manage brake temperatures throughout the entire descent. The Tesla Semi takes a completely different approach. Instead of wasting that energy as heat, it uses regenerative braking. As the truck travels downhill, its electric motors act as generators, slowing the vehicle while sending energy back into the battery pack. In simple terms, the descent doesn't just save the brakes, it helps recharge the truck. This offers major advantages beyond efficiency. Because regenerative braking handles most of the speed control, the traditional brakes experience less stress, lower temperatures, and reduced wear. Maintenance requirements decrease, and concerns about brake fade become far less significant during normal operations. According to Matt McClelland, Vice President of Sustainability and Innovation at Covenant Logistics, drivers who tested the Tesla Semi on the grapevine reported a level of confidence that was difficult to achieve in conventional diesel trucks. That's a notable observation. Professional drivers with years of diesel experience found themselves feeling more comfortable behind the wheel of an electric truck on one of America's most challenging freight routes. Real-world results. Continue to build. The positive feedback isn't limited to a single company. ArcBest evaluated the Tesla Semi over nearly 4,500 miles of freight operations and recorded average energy consumption of 1.55 kilowatt-hours per mile. DHL Supply Chain completed roughly 3,000 miles under full load conditions and reported 1.72 kilowatt-hours per mile. CEVA Logistics also documented measurable emissions reductions during its testing program. Meanwhile, port freight operators such as MDB Transportation and ALO Logistics launched dedicated pilot projects to evaluate the truck in daily operations. The pattern is becoming increasingly clear. Across different companies, routes, and cargo loads, the Tesla Semi continues to demonstrate strong performance, not in controlled laboratory settings, but in real-world freight operations. The bigger story. Software. While much of the attention focuses on batteries and operating costs, the most important part of the Tesla Semi may be something far less visible: software. Tesla isn't simply building a truck, it's building a vehicle designed around future automation. Every Tesla Semi leaves the factory equipped with advanced cameras, sensors, and computing hardware capable of supporting autonomous driving features. Much of the necessary infrastructure is already built into the vehicle. That means future capabilities may arrive through software updates rather than new hardware purchases. As autonomous driving regulations continue to evolve, many logistics companies are already studying how these technologies could reshape freight transportation. One concept attracting significant attention is platooning. In a platoon, one lead truck is operated by a driver, while multiple following trucks travel in a tightly coordinated formation using advanced software and AI systems. By reducing aerodynamic drag, the trailing vehicles consume less energy, improving overall efficiency. The fuel and energy savings alone can be substantial over thousands of miles. But the potential labor advantages are even more significant. If automation continues to advance, a single driver could eventually oversee the movement of multiple trucks, dramatically increasing freight capacity while reducing operating costs. Whether that future arrives in a few years or takes longer, one thing is becoming clear. The Tesla Semi is more than just an electric truck. For many in the logistics industry, it represents the foundation of a new transportation model built on efficiency, software, and automation. Why early adoption could matter. If autonomous trucking becomes commercially viable, the economics of freight transportation could change dramatically. Today, driver wages and benefits account for roughly 35% to 40% of long-haul operating costs. Technologies such as autonomous platooning could significantly reduce that expense by allowing multiple trucks to travel together under coordinated control. In that scenario, companies that adopted Tesla Semis early would have a major advantage. They're not just buying trucks, they're building experience, collecting operational data, investing in charging infrastructure, and optimizing routes long before competitors enter the market. Every year of early adoption creates a head start that may be difficult to catch. For decades, trucking companies competed on horsepower, fuel economy, and engine performance. But the next competitive battle may be driven by software. That's the shift many industry leaders are paying attention to. What the real-world data shows. Several major logistics companies have already tested the Tesla Semi in real freight operations, including ArcBest, DHL, Covenant Logistics, and CEVA. These are businesses focused on profitability, not technology hype. Their evaluations suggest that the Semi can perform effectively on demanding freight routes while delivering lower energy consumption and reduced emissions. That doesn't mean every challenge has been solved. Large-scale charging infrastructure still needs expansion. Long-term battery performance over many years of heavy commercial use is still being evaluated. And supplying enough electrical capacity for thousands of high-power chargers remains a significant challenge for utilities and policymakers. These are real questions that will need real solutions. The debate that will shape the industry. Not everyone is convinced. Many veteran truck drivers have seen countless technologies promoted as the future, only to fall short of expectations. Hydrogen fuel cells, natural gas trucks, and other alternatives have all generated excitement before failing to transform the industry as promised. Their skepticism comes from experience. On the other side are investors and logistics companies looking closely at the numbers. They aren't necessarily betting on the technology itself. They're betting on the economics. And for the first time, those economics are being supported by data from actual freight routes and real-world operations. So perhaps the biggest question isn't whether the Tesla Semi can do the job. Real-world testing has already shown that it can. The real question is whether electric and software-driven transportation will reshape the trucking industry over the next decade, or whether it will become another ambitious idea that never fully delivers. The answer is still being written on highways across America, 1 mile at a time.